So our first topic is going to be warehouse loading dock operation modeling. So as I said, we're going to be focusing on some example files that we offer along with the installation package, and then go into the details. So these are the warehouse loading docks that we're talking about. So there are a lot of those warehouses and distribution centers, or some of the other cases where you need similar to this, what you're seeing, types of operations to be modeled in the simulation model. So that's what we're going to be going over, and there are a lot of components. So hang tight. I'll try to go slow and try to cover everything. But if there's anything missing, or anything that you want us to cover again, you can take advantage of using the questions and answer section. So the first model that we're going to take a look at is this simple loading bay model that you can find under examples, training, parking, truck reversing, loading bay, -simple.impx file. So this is how the model looks like. So and the purpose of this model is to give you an idea on how that loading bay operation or loading dock operation could be achieved by using Vissim. So first and most of all, you can see that there's one main link where all the vehicles are going to be using to travel, and then there will be another link that goes parallel to that link, where it's going to be used for the reversing and parking activities. And as you can imagine, the truck will move forward and then pull forward, and then make that the truck and trailer to be straight, and then move, changing the gear to reverse, and then move backward and park at the loading dock location, loading bay location. So this is how the geometry looks like. As I mentioned, there is a one straight link that allows you to travel all the way, and then there are some connectors that's been created reflecting some of those turning radiuses and all that for the truck and trailers, which will put them on the different link, which is going to be the links and connectors for the loading bay area. So there are not a whole lot of surprises in there, but one thing that you'll need to keep in mind is that from the time that truck will back out and revert, being in a reverse direction, and travel all the way and until it gets back to the main static route itself, it will not have any set sequence of links and connectors defined for it to travel. So from the time that it's going to leave that particular link where the parking lot is placed at, what it'll do is, as it starts backing up, it's going to try to hop onto the first connector that it's going to see. So in this particular case, we made sure that the connector that you see as a straight line is being placed much further downstream, even it could be an inch or what, than the other connector that where you see that with the curvatures. So this is one thing that you'll need to make sure that you're doing. The other component is that first and most of all, the part where I was marking as a reversing direction is now you're going to see that to be marked as a parking space. And then similarly, in say the parking space, you're going to see that area on the left side to be called as a reversing direction. That's because we're not necessarily using parking space for parking itself, but we're using that parking lot to initiate that parking behavior, and actual parking behavior is going to happen in the form of reversing direction time. So you're going to see more details about that in a bit. So the other component is routing. That routing consists of two parts here. A static route will take you from one end to the other end, and then parking lot route has to be placed at the downstream of that static route. It's like decision point, and then it will be able to. There should be a valid connection for that particular truck or any other vehicles to come back to its original static route settings. Okay, now once you place that parking lot on that link on a forward, the part where the truck will change its direction, there are a couple of settings that you're going to need to check. First and most of all, you're going to need to make sure that the parking lot type is real parking space, which is default. And the other portion is that this parking direction. Now there are much more options than we used to have. In the past, it was like forward only. Now there are 3 more options that you can choose from: forward, reverse forward, any in opposite direction from whatever direction that they chose to go in. In this particular case, for this example file, we have to choose forward and reverse because we want those trucks to pull forward in and then try to reverse out. And the other aspect in here is that there are direction change time distribution. Again, it's nothing but just a time distribution, which will be used for Vissim to measure how long it's going to dwell at the time that it has to change direction. In this particular case, it was going reverse, and then and it's going to start going forward, and the time that it takes to change that direction is what you're defining here. So in reality, what you'll need to put here is going to be actual parking time that you would like to see. So in this case, we have chose to go with the distribution number 30, which is plus minus around an average 30 seconds of parking time. Now, there are other aspects like what I've mentioned. Parking route will need to define will be coded in a way that there is a decision point, and then where that route is going to be, what parking lot that is going to be tied to. And for that route, you can actually code in that parking duration. But as you remember, I know that could be confusing, but it's opposite. So that actual parking time that we're going to enter over there is going to be the direction change time that we want it to have. So the truck driver will, can pull forward and then change the gear to reverse and then start moving back, backward. That's how long it, that's that duration, exact duration of time that you want to have, that you want to see in there, is something that you're going to enter in this parking duration as well. In this case. For to manage the conflict, we have placed a couple of different conflict areas to take care of those typical conflict that you're going to see, for diverging and merging behaviors from and to the main roads. For the rest of the other priority rules that you're seeing over there with the orange bar and the green bars and so on and so forth, those are the priority rules that Vissim will create on the fly. So if you create those reverse and those parking lot which will have anything to do with the reverse movement behavior, Vissim will detect some of those conflicts, and then it will place those priority rules automatically, which we're gonna take a look pretty shortly. So let's take a look at the Vissim model itself and let's see how it looks like. So this is how that Vissim model looks like here. Let me close out some of those tables that I don't think that we're going to have. So this is how it looks like. And if I press Control A, and let me turn off this conflict area so that we can focus on those links and connector settings, you can see that there are 1 links and there are now the connector that which is reflecting that actual turning radius that truck and trailer can have. And there are 2 links that is placed at the actual parking space, and then the part where we want the truck and trailer to change direction. So like what I've mentioned, if you look at, let me zoom in all the way so that we can make the point clear. So this connector is placed at the further upstream than this another connector that you see here. So you see that there's a gap here. So that's what I was trying to explain in one of those previous slides. So when it's moving backward, it's going to pick up whichever the connector that comes first is. So in this particular case, it's going to pick up this connector, which like will take them to go like straight to the left or backward straight instead of the other connector here. But if you reverse it and then set things to be like more like this, and what you're going to see is that like that truck will pick this other connector up, and then it's going to reverse out, like by using this connector. So you may want to pay attention to that and make sure that like you place the endpoint of that connector that you want it to take when it's backing out to be placed further downstream than the other ones. All right, and then some other stuff that we have gone through is like this parking lot here. Make sure that like real parking space is selected, and parking space has this like parking direction to be chosen to be correct, forward and reverse. And then direction change time distribution could be found here. And again, this is a time distribution that you can choose from. So if you would like to update this time distribution, you'll need to go up to base data, distribution, and time. That will allow you to add those time distributions here. You can add any time distribution saying you want normal distribution. In my case, let's say I want this truck to be parking there for 1 hour, 3,600 seconds. And then standard deviation to be 0, so that every truck's going to park there for 1 hour exactly. Then you can do that and click OK. And when you go back, you're going to get that option from here as well. I mean, you're going to see 40 and nothing here because I didn't enter anything for label here, as you can see here. So you can create some name of this like distribution. Then it's going to be easier to find out what the details are going to be. Okay, I'm going to cancel out of this. And the other component are the routings. So as you can see here, there's only one routing here for static routes, which will define where that truck and trailer should be traveling to in general. And for downstream location, you're going to find a parking route, as you can see here. If I double click on it, it's going to give me an idea on what that is looking like. And then as I've mentioned, we're going to see a parking direction and parking lot, and some other information here, such as where it's going to be going to and from, and so on, so and so forth as well. So once it's done, what I'm going to take your attention to, is like those conflict management. To do that, I had to close some of those tables that I'm not going to be using. So as you can see here, currently it has conflict areas, and as soon as I start my simulation, you're going to see that those priority rules are going to be created automatically. So don't need to worry about some of those priority rule creation portion if your loading bay is simple enough, like what you're seeing here. Okay, if I run this, one of the other point that I wanted to make is that this truck's coming. My computer's struggling, but still. And you're going to see that those trucks are just passing by instead of stopping there. And you would think that why would that be the case? One of the first things that you may want to check is the length of that truck and trailer. So in this particular case, it's 66 feet, while your parking space is only 62.369 feet. So you'll need to make sure to create a parking space which is long enough so that it can accommodate all those trucks and trailers as well. Okay, so I'll stop simulation to give a little bit of a space in my computer. Okay, and then I'm going to go back to the slide then. So let's take a look at some of those cases which are a bit more complicated and complex. Again, The model that you're seeing on the screen now is also something that you can find from example file folder, which you can find from examples, training, parking, truck reversing, and logistics center and logistics center hyphen at mod.impx. So at mod here is attribute modification. So let's take a further look at this. So this has more components, but in principle, it's quite the same. So there are like roadways that will take you, I mean, all the vehicles are going to be traveling east and west. And then there are like, spaces where truck will pull forward and then like, be ready to use that space to change the direction to reverse. And then actual parking space. And then in this particular case, we have added the circulation road just in case if they have to go out because there was no space available. So like what I mentioned earlier, even though that actual space where the parking lot's placed, the actual space where the parking lot or objects are placed are going to be used to reverse the trucks and trailers direction. And actual location where it's going to change the direction in Vissim will be used for parking as well. So I know that it's opposite from what you would think, but like that's how this model is built. So let's keep that in mind. And this is how overall link and connector structure looks like, if you zoom in. So first and most of all, all the truck and trailers are going to be entering the network by using that feeder link heading north. And then depending on which bay that they're going to be parking at, they're going to make 90 degrees turn to the right. And of course, that links and connectors are reflecting that turning radius that that particular types of trucks that you're modeling is going to be taken. And then once they pull forward and whatever time lapses that that you have defined, it's going to pull backward, like what is shown on arrow number 2, and it's going to go all the way to the back. And then when it's done dwelling at that loading bay and loading dock, it's going to pull forward and then leave this area by turning right and make another 90 degrees turn. One of the other tricks that you'll need to be aware of or keep in mind is that you're going to be curious to see how far that truck and trailers are going to be backing up on this link on the left side. It's not going to go all the way to the back, but it will go just far enough to accommodate the length of this parking space that you have defined here. So if your parking space is defined as the length of the parking slot that you have defined here is like 60 feet, then the truck and trailer will go backward and move to the reverse direction for 60 feet from the actual connector that it'll need to take to move out to leave this space. So if you want to put that those trucks to be pulling backward much further than that, you may want to make sure to adjust that parking space length as well. Conflict management, there's nothing very special about it. Typical crossing and intersecting and some of those merging behaviors are taken care with the conflict management. I mean the conflict areas, conflict areas. And in this particular case, there's something more than what we could see from the previous simple example, which are some additional priority rules that we have defined. Those priority rules are defined there to make sure that there are no overlapping vehicles, which might be caused by some of those different turning radius for those vehicles. For example, those when trucks pulling into this and then take this particular links here, you want to make sure that it's not going to be collide with this truck which will back out from this one as well, this link, which is going east-west as well. So those are the types of priority rules that we have set up. Those will need some fine-tuning as you go through the modeling process. All right, so here's one another interesting stuff that I'm going to point out, which for this priority rules. Before we had a concept on like vehicle traveling in a reverse direction in Vissim, we didn't have to have this like object or attribute say like affected driving direction and effective driving direction on both on like stop line and conflict markers. So now, because like there are some cases where vehicles going to travel in a reverse direction, now you'll need to check and see what will be the affected actual like driving direction for the stop line. In this case, like it's going to reverse because we're trying to make sure that like those trucks are going to be stopping there if there's any other truck that's like making turns at that same time. So and in some cases it could be forward or reverse. So that's one thing that you'll need to check. And also to make things easier, maybe it's going to be a little hard to see here, but starting from last version, you can see that like with an arrow that like what the affected driving direction actually is visually on the network editor as well. So that will make your coding process or double checking process a little easier. So after that, like what I mentioned earlier, once you start running the simulation, you're going to see that like Vissim is going to create a couple more priority rules that's going to be needed for it to operate as well. So there are like a lot of the other interesting aspects in here, but it will make you feel dizzy. So hang tight. So first and most of all, like what you might have noticed as a difference in between the model that I was using before this and this, which is like it has a lot more loading base. So you got to figure out how we can have that like truck to go into that bay or not, depending on the occupancy, right? Whether that bay has been occupied or not. So to do that, we're using a couple of different objects in Vissim or features. First is user-defined attributes, and second is attribute modification, and third one is going to be vehicle attribute decision to update those status of the vehicles and some other aspects. So in here, there are 4 user-defined attributes that are being defined here, which is first vehicle state. So this vehicle state will give you an idea on whether that vehicle has been parked, pulled into this loading dock area, or it's just like it was being served and then trying to get out of that area. So it will have a certain vehicle state numbers. So as you can see that the data type is integer. And also there's another one called like vehicle exit load area, which will assign like a value 1 for those trucks who came in and then and all the stuff has been taken care of and on its way out of this loading area. The third one is area full which is Boolean, which will give you an idea, which will give all the vehicle an idea that whether this loading dock area is full and not being able to accommodate one more trucks or not. So that is being done by using table lookup here, and I'm going to talk more details in later slides. The last one here is base available. So and as you can see, this is an integer. So this is the data. This is the attribute where it will hold the types of information on like how many bays are open and available, which we're going to talk about in a bit. And these are some of those data. And I think I should say that like these two, 1 and 4, are updated by using attribute modification, while this number 2, which is like vehicle exit loading area, is updated by vehicle attribute decision, which we're going to cover a little later. And this particular area full attribute is being updated by this formula itself that you can see here. Of course, it is related to another user-defined attribute. So now, in this particular case, we wanted to have a way that we can store that data, number of bays available data. So instead of tying it to any other existing object, we pulled in another object called sections. It's not going to be used for anything, but only for the nothing but just to hold the data. So that the section will have a user-defined attribute that you can see in the previous slide called base available, and by default it's going to be set to be 8 because there are 8 spaces here. The next one is the most exciting stuff, I guess, which is attribute modification. For those of you who've not used attribute modification, this is one feature that you could be using to update all those attribute status without needing to use any of those scripts. So, and also the good thing about this is that like everything's going to be stored in here, and everything's like all referenced directly to any other objects and attributes that you might have. So there's no chances on making like any syntax errors and stuff like that. So attribute modification has like it consists of two big parts. One part is to update the vehicle status. So if it takes first of all in here, when a vehicle is entering the network, that vehicle state attribute, user-defined attributes set to be 0 or null, because which means that there's no data assigned to it. And by the time when those vehicles entering and crossing that routing decision number 1 or 2, which I'm going to show you what that looks like, and then if the route number is equal to 1, and if that doesn't have a state, it will assign vehicle state number 1 like it is shown here. And there's a simple process that it takes, like if that state is 1, really soon after, within the within the same time step, it's going to change it from 1 to 2. And if that state is, vehicle state is like at 2, and then and also if vehicle exit load area turns into 1, then it is going to update this vehicle state to 3, and 3 to 4 within the same immediate time step as well. So those are also primarily being used to count the number of bays available. Initially, on the top, you can see that initialization happens, and number of bays available is going to be set to 8 upon before simulation starts. And then once you have that section number 1, because this is tied to section here, and it's going to look for that vehicle information, which is taken which is in the vehicle state 1, and the one that took routing decision number 1. So if it returns any of those vehicle ID number, which is non-zero, then it's going to try to deduct that total current number of available bays, loading bays available by 1. Same thing for decision 1 or 2. That's what it does. And then the 7th one here, which is 4th for this bays available calculation, and if that status vehicle state changes from something else 2 to 3, it's going to be triggered at counter, and then add that one more number of bays available to be, add one to that the current bays available information, so that it could go back up to whatever the other number that should be. So similar to what we've seen before, you'll need to make sure that parking direction is set to be accurate, forward and reverse. And then also you can define a different parking time by updating that information or data in direction change time distribution. So this is what this slide shows the static routing here. So route number 1, static route number 1 starts from here on the left and travels all the way to the other end. And then routing decision number 2 starts from the right end and travels to the left end as well. You could have multiple combinations as well, if you will. So in this particular case, 1 and 2 are set there are 2 routes available for each of those routing decision. 1 is going to be taking that truck to be going into this this loading bay area, and then 2 is going to have them bypass. And that's going to be done based on the area full user-defined attributes. So if that area 1 is true, area full attribute is true, then this will take place so that all the trucks and trailers are not going to be pulling in, but they're going to just bypass because there's no space available. If that's not true, because as you can see, like there's an exclamation point here, they're going to pull in and try to look for space. Now, once that truck gets pulled in, now it's time to figure out, like, where do we want them to be parking at? So after this point, after we have that truck pulling in by using that static routing, now partial route takes an action, and that plays the role here. So what it will check is as you can see, there are a whole bunch of if statements here, and it's going to look for that particular information such as routing decision type, and then routing decision number 1, which is actual routing decision number that I have for this partial route. If that 1 and 1 for partial route or parking lot route is true, then it's going to return that vehicle ID number. So if Vissim sees any of those vehicle ID number, then it will take that as there's something there. So it's going to turn that into a 0, because that has already been occupied. So for example, if the 3, 4, and 7, route 3 and 4, 7 are being taken, then those are going to be not considered as an option that each of those trucks can take from. So 1, 2, 5, and 6, and 8 will be chosen, and then and truck will choose that from those 4 or 5 options in a random manner, as a random distribution. So once each of those truck gets gets assigned to any particular partial route out of 8 partial routes that you can see before, it will let those vehicles to go over that particular dummy connector that is being created here. So there are 1, 2, 3, 4, 5, 6, 7, 8 dummy connectors that you can see here. So if that is assigned to partial route number 1, it's going to take this first dummy connector here. For the rest, it's going to bypass this connector. Second one, the same. Third one, and so on and so forth. So when this particular vehicle goes over this first dummy connector, then it's going to pick up this parking lot route, which is placed on that first dummy connector. The rest, it's going to bypass those. So the other parking lot route will not be seen by that particular truck and trailer. So parking lot routes are again all being placed on that dummy connectors here. So vehicle attribute decision, as you can see here, there's a separate menu for those of you who've not used it before, is being placed at the exit point. So once all this truck and trailer hits that point, it will be set, it'll, or the attribute for each vehicle called vehicle exit load area is going to be set to be 1. So it's going to be used again to update that number of bays available information. So let's take a look at that model in Vissim. So this is how the model, in general looks like. In 3D mode, this is how it looks like. Yeah, it looks pretty decent, I guess. If I turn this into a wireframe mode or centerline mode, you're going to see a whole bunch of more links and links than what you would expect to see, which are being put there as just to show some of those lane stripings and additional areas where where pavement is at as well. So let me turn off this conflict area so that we can see things better. So there are this static routing that goes all the way, 1 or 2. 1 goes in and 2 just goes bypasses it. Static routing number 2 has the same. 1 goes in and 2 just bypasses it. Okay, and then the other aspect in there is, if you come in here, you can see that there are quite a few of those dummy connectors. 1, 2, 3, 4, 5, 6, 7, 8, I think. Okay, And then like, that's going to be picked up by the partial route that is being placed over here as well. So each of those partial route, not parking lot route, partial routes, sorry, parking lot, partial route will have 8 options to choose from. And as you can see, there are formula assigned to each one of them, checking and seeing whether that particular partial route and parking lot route was taken by any vehicle or not. If it was taken, that's not available. If it is not, that is going to be still staying available, and then it's going to return 1 again. And if it is not available, it's going to return 0. But depending on that, each of those parking lot route is going to be assigning those vehicles to each of those parking lots in here. And parking lot has this forward reverse setting, and then direction change direction change time distribution is set to be 2 minutes, which could be increased or decreased as you need. But this is actual parking time that you will need to update. And here's this section, like what I mentioned, which is just like nothing but just a data holder, a placeholder for data, for the database available data. And real quick, I want to show you this user-defined attributes, saying like, this is vehicle state, nothing but just a data field, and then vehicle exit load area, data field, and formula here, which is area full. What it's going to do is that like it's going to check and see whether this base available data is greater or or less or equal to 0 or not. If that is equal to 0, then it's going to say like area is full. Okay, the other aspect that you may want to see is, where is it? Test actions, attribute modifications. So attribute modification has a lot of interesting stuff, which I don't think that we have time to go into very details. But you can see that like there are like some settings such as like is this routing decision number 1 or number 2, and is that route number 1 and state 0, then it's going to return a value of 1, and then 2 and 3 and 4, similar to each of the other cases that you might have seen in the past. So I'll turn this on and then change this and run simulation. And as you can see that it's going to create some of those additional priority rules. And like what I mentioned earlier, depending on the direction that it is set, it's going to display the arrow right above, right beside it as well. So you can see that where that green how to call it, this stop bar is going to be affecting. It's affecting those vehicles which are backing out. So let me turn off some of the other unnecessary information. So you can see that trucks pulling in and they're gonna be pulling out. And another information that you can see is that truck has routing decision number 2 and 1, and state is 2 because it has that assigned to the parking static routing the information assigned to it, and then it's updating to 7 and 1, which means that this vehicle will go to dock number 7. So you're going to see that it's going to take a little time for each of those truck and trailer to pull in, and once the area gets cleared out, this travels and then pulls into the 7th slot as well. Again, this is a random assignment, and then also depending on the available space. And as you can see that this truck and trailer is waiting for this truck and trailer to pull back out because it's started getting to that area ahead of this. And one additional information that you may will find out to be interesting is this this 3D information sign. So in 3D mode, let me just try to zoom into that area real quick. You're gonna be able to see that there are X number of loading bays available. This is by using our relatively new 3D information signs. So for this particular sign, like I selected this, so it highlighted, in here, could be edited by using this 3D information sign here, and you can add all those contents and attributes in here in a way that you want, and then add in any other text that you want if you want to add anything. So you can fine tune that further from that point on, and that will allow you to update that information interactively.